So you've got a BMS, you've got a vehicle controller, you've got some cells and modules and a battery together. What's the most important thing next? Well, actually, safety is the most important thing over all of this. And there are numerous things that you need to read in the rules about how you manage an energy store, that is a battery, safely. So there are multiple systems that help us do this. The first one is your BMS, and we talked about that in the last segment. And that BMS will interface with your vehicle controller. There'll be other things that are coming up to your vehicle controller as well. The first one, which is mandated in the rules, is an isolation detection system. This also sits within your energy case, and it looks at the high voltage circuit. You don't need to go into the detail of how it works here. There are plenty of useful documents on the supplier's website. But if you think about it as a leak detection mechanism for your high voltage system, then you're pretty close to how it works. But essentially it's saying your high voltage system has to be completely separated, insulated, and removed from your main vehicle grounding system, so the metal of your chassis, the carbon of your chassis, and the 12 volt systems. Your high voltage and your high voltage earth and your 12 voltage earth should not be the same. They cannot be the same. The two have to be isolated. And that isolation system is the one that tells you whether or not your system has a sufficient resistance, measured in megohms, between the high voltage and the low voltage systems and their earths. So that's a key safety feature. The other one that you need to be able to measure to work out how much power you're generating is both the voltage at the battery terminals and the current that you're flowing out to the inverter. The inverter will probably tell you this too, but you should also measure it within the battery so that you know and can look at the BMS. The BMS will tell you the cells are this temperature and the cells are this state of charge, that much charge, they're at this voltage. And you should then be able to say, well, this is how much current I can safely flow. Your current measurement will tell you that, your voltage measurement at pack level will tell you that, and your BMS will give you some corroboration as to how the cells are operating, temperature-wise, voltage-wise, state of charge-wise. And from that, you can run the whole system safely. And it's very key that you do that, and especially when you're running the car, but also when you're charging the car. It's another thing that we need to give care to, that a battery needs to be charged. And the BMS and your vehicle controller and your charging system, which you also have to create as a team, that has to run well too, and it all has to be part of the same system so that your charger recognizes the BMS and you can work together and safely charge the battery. It doesn't get too hot, you don't charge it too fast, the voltage doesn't rise too high, so that you don't end up in a situation where you create a damage to the battery, or you run that whole thermal event situation, which none of us want to see. So safety is key, so please read the respective rules on isolation measurement, current measurement, and your battery management system. They really are important for the protection of you, the protection of your car, your event, and also the investment in all those cells and batteries. And no one wants to see a failure at the track, and no one wants to see a vehicle not being able to compete. So make sure you design those systems well. They really are important.